comfortable with that because we will be sharing the recording afterwards on YouTube. And then we are good. And I think everybody has also read and reviewed the code of conduct, just making sure that our learning environment is a safe and inclusive one for everybody here today. So we'll be enforcing that and taking that very seriously, and we'll be removing people if there is any violations of that code of conduct. Yeah, I think I have gone through the housekeeping items, so I think, yeah, we can get started. I'm going to switch my screen over to my Posit Cloud page. It'll give everybody a second to make sure that they're logged in, and you should see this screen. Can I get everybody to put in a green check mark once you are in and ready to go? Eight is about the critical number here. Perfect. So everybody is logged in. You should still have.
Hey, Jasmine.
Yes.
People are having issues hearing you. Could you maybe speak a little louder?
Okay. Does this help a little bit more?
CC, is it better? Yeah.
Okay. Thank you for letting me know. Sometimes it's hard to tell. But yeah, if at any point you have issues hearing me, feel free to unmute or put it in the chat, and one of the organizers will let me know. Okay. So yes, we are in our studio right now. And then for this section, I want to create a new R Markdown document for part 2. So doing what we did before, I'm just going to create intro to part 2. And then just okay. Oh, instead of pressing OK, this time I'm just going to create an empty document so it doesn't populate with the default content from the R Markdown that it usually does. But if you already created it, feel free to just remove that default content, as we won't be needing that. I'm just going to start with a heading for this part for data structure. First, then I'm just going to save this R Markdown document back in that folder that we created before for scripts. I'm going to give it a file name. I'm going to say save that. Okay, perfect. My R Markdown document created, and then yeah, I can create a new code chunk in R by doing command option I, and then I'll create the code chunk. And in that code chunk, I'm gonna create this new thing that's called a data frame. So here, I'm just gonna create this data frame, data.frame. And in this data frame, I'm gonna have one column coach. And then for coach, I'm gonna have calico, black, tabby. And then for the other column, I'm going to do weight. And then in this vector, add in some numbers. So put in 2.1, 5.0, 3.2, and then I'm going to create another column called like string. Put 1, 0, 1. And then I need to assign this data frame to something. So I'm going to call this cats. You might have noticed you got everything correct. So if you want to show it in your R Markdown, you write cats here, and then you should see a data frame that looks like this. Clear feedback, and if everybody has their data frame set up, I get everybody to put in a green check mark, just so I know that everybody's caught up. I'm just going to scroll back up here, so if anybody still needs to see the text, I'm just going to Command I here to kind of realign things just so it's easier to read. So Command I just helps with the indentation. It doesn't really matter in the coding of things, but if you look back at your code, it'll be easier to read if you have that. Yeah, and if you have any issues creating this data frame, let us know, because we'll be using this data frame in subsequent items that we'll be going through.
We have a question, Jasmine. The question is the data frame equivalent to a row in a spreadsheet / SQL table?
I would believe it's for SQL tables. It would be equivalent to that, I think. Yes, as Melissa said, like the full table would be the entire sheet in like in an Excel sheet that you would be seeing. So one row would be here Calico 2.11. This would be considered a row, and then this entire data frame is like, yeah, that sheet in Excel where you have some columns and then some data associated with that. And then we'll look more into how do we get data from this, or like particular information that we're interested in from this CATS data frame. This is a bit of a simple example that we're starting with right now. Typically, you might not be creating your data frames like this here, where we've manually typed everything. Your data collection process would be kind of slightly different. You might be entering it into a spreadsheet or something like that, but for our initial learning case here, we will use this like simple data frame to learn from, and then we'll show you a bit more of a complex example using like the Gapminder data set afterwards. Cool. And then, yeah, if we want to save this data frame, you can write this to a CSV, and a CSV is a comma separated values file type, which will take the data and then separate it using a comma, and that's like the delimiter for this file type, and that's how we identify the different values here. So it might make more sense once we create it. So I'm just going to go down here to create a new code chunk. And then in this code chunk, I'm going to write write.csv. And then for the first value X, I'm going to put in cats, which is the data frame that we just created. And then for file, I'm going to write it to somewhere. I want to make sure that I keep all my data files together. So before I even do that, I'm gonna go down to the files pane down here and then press this new folder icon, first one in the row here, and then create a new folder that's called data. Okay, so now I've created the folder data. So then I want to save this CATS data frame to the data folder here. So I should be able to go data slash feline data CSV. And if I run that, that does not work because the directory location is incorrect, because right now we're in our markdown folder, which is inside of scripts. So should be able to go up directories, just double checking, because you can actually use RStudio's autocomplete to help you fill out the file path here. So if I didn't have this before, I could use this tab completion after I started with the ... and that just allows me to go one up from the scripts folder to this main projects folder here, and then save it in the right spot. So I still need to give this file a name. So I'm just going to use my
Hey, Jasmine.
Yes.
Can you actually show your CATS data frame again? We have some errors. So I just wanted to point out that there are commas at the end of every line. So quote, and then comma, and then wait, comma. So those are important to make sure that we're ending those lines with commas. And that, I think, should fix everyone's problems.
Yes.
Great, thank you. Sorry about that.
No problem. It's important that everybody gets the data frame working so that we can work with it afterwards. I'll also try to maybe make this a little bigger so people can still see the original data frame while we type in this read CSV section. And then write CSV, and then the last argument we want is row names equal false. So that just prevents it from adding automatically row names in there for the red.csv function, because we just want the data frame as we see it here. And then we'll run this line, and yes, now I'm directing R to put it in the correct file path. So now if you go into the files pane here and then look into the data folder, you should see that feline data CSV file that we created earlier by running this line. And then you can also click into the CSV file, click view file, and then it'll open it up in RStudio here, and you can see compared to kind of what we've created here in the R Markdown, we've saved exactly that in here in the CSV, and you can see that each item is separated by a comma here, and each item is in a new, or each row is in a new line here. Anybody have any issues with getting to this point? Just wanted to check your feedback. Is everybody good? Everybody is able to save their feline data into a CSV?
Could you go back to your code again? We have a question. So what is the second chunk supposed to show? Can you explain that again?
This chunk or the
I don't know. Sephora, do you mind explaining? Oh, the right.csv. Yeah.
what is it supposed to show? As in, like usually what we've been getting is like some output below the code chunk. Is that what you're referring to, Sephora?
Maybe you can explain what it does.
The right.csv function. Yeah. So that takes what we have right now in our R markdown, and then that cats variable that we created, and then actually save it as a CSV file. So it no longer kind of lives in just our environment, but actually we've kind of written that information out that we've typed out here into external file, kind of like what you would save in your Excel file as feline-data.xlsx, kind of a file like that, where you can share this information with other people without them having to use R or kind of being in your same workspace. So this is kind of a common data file format that people use that's nice and not proprietary compared to Excel. And you'll probably see a lot of files that are shared with you containing data be in this format. And running this line, we don't expect output, kind of like what we had above in the cats when we created the cats data frame here. Down here, we're writing a CSV. Not all functions will produce an output. Some are silent by design. In this case, the right.csv doesn't produce an output here in R, but it does create this new file in our data folder here. So hopefully that clarifies your question there, Sephora, but yeah, let us know if you have any issues. I also see some people having issues with saving the CSV file. Make sure that you also have that. If you also have the same folder set up as me, because right now I've saved my R Markdown file in the scripts folder. So that'll make a difference on kind of what folder path you'll need in order to save it into the data file. And
maybe you can show the get WD function again.
Yes. So Yuka mentioned the get WD function, and that allows me to figure out where I am within the folders. And right now, if I run get WD in this markdown folder, I get cloud project scripts, which tells me that I'm in this folder, but I want to put the data in the data folder here. So in order to do that, I need to do the ... /data, and the ... is just going one level outside of scripts. So I go back to the cloud/project directory, and then from the cloud project directory, I'm telling R to save it in the data folder. Without the ... here, if I try to save it, then I get the error I was getting before, because what R is doing is because my current working directory is the cloud project scripts. It's looking in this folder, looking for a folder called data, but it can't find it. So if it can't find it, then it won't be able to save the data. So that is why you'll probably be getting that error. So that also shows the importance of having the correct folder paths, because R will only be as good as the instructions that you tell it, and it's very literal and will just take what you give it and try to execute it. So our job is to kind of give R those instructions to do what we want it to do. So hopefully that helps. If you need any additional troubleshooting help, yeah, feel free to put that in the chat, and then one of the organizers should be able to help you troubleshoot.
Yeah, so maybe I'll create a breakout room and
Okay,
folks
perfect.
can join and share screens and stuff. Who is having issues saving this file? Put up a red X and I'll put you guys in breakout room with me, Melissa, and who? Melissa, CC, do either of you want to stay in the main room?
I can stay in the main room.
Okay,
Yeah.
so I'll bring CC with me. So hopefully I can see everyone with an X. All right.
And yeah, I won't go too quickly, Yuka, and I'll let you, when you come back, let me know, and I'll try to get you guys caught up.
Yeah, so I'm letting participants choose the room. So I'm creating one, and then for those of you who just put up a red thing, come on over. Did I just create one? There we go. Oh, now I'm recording this page. All right. Who wants to start first?
To be able to use type of investigate these column types. Hey, Yuka, welcome back. Everything good?
Yeah, sorry I messed up the recording. I think it followed me.
Oh no. Oh well. I was just talking about types and different types and how to get the types of a column here using the type of function, and just showing the how to kind of do simple calculations with the column values, and manipulations like using paste to put together values in a column with just one character value here. Yeah, that's a recap of what happened. Didn't miss much since you left, but if anybody who went with Yuka to the breakout room needs any help catching up, feel free to throw something up in the chat. Cool. Yeah, and you can kind of do type of on any variable that you create in R, so that you can inspect kind of what they are underneath. And then what? Okay, new R code chunk. And then we're gonna now try to read in that CSV file that we created earlier using write.csv. So as a complement to write.csv, there's a read.csv. You can see that RStudio really conveniently helps give you all the different options that you have for read dot something. So there are other options in reading for different file types. So yeah, feel free to check that out there when you have time, or if you're trying to look for a way to read your specific data file. Sometimes there's an option there, and there's also other packages that allow you to read other file types. Probably people are most interested in like reading Excel files into R, as Excel is really popular. It's not right out of the box available in the base R, but there is a Excel package that that reads in that type of data in particular. So yeah, in read.csv here, I am going to go in the first argument file and read in that data file. So I will need to use the // go up a directory, and then I should see the data folder. So hit enter to tab complete that. And then, oh, I don't even need to do anything because there was only one file in that folder. So once I hit tab, it helped me automatically fill in the feline data.csv file name. And then if I just read .csv here, I'll get the data frame, but I'm currently not saving it to a variable, and I want to do that. I'm just gonna call this cats. This will overwrite the data frame that I created before because I'm giving it the same name. That, let's save that CSV file. And then I want to use type of to inspect that.
So we've got a question. What is the difference between type of and class?
I don't actually remember the difference between type of and class, but one nice thing is that I can just go into the console here and read the help documentation for type of and class here. So I'm just going to go here and read class question mark on that to just take a look. And also in R, there's like kind of multiple ways to usually do one thing. So some people might prefer type of, some people might prefer class, and they might provide like similar information or slightly different information. So it really depends on kind of what your use case is and kind of what you are more comfortable in using. So yeah, class is just a simple generic function for that. So if I just do class weight numeric, yes, that's the thing. But if I do type of class weight and run that, that's double. So it's showing me two different ones. So oh yeah, so it's showing me class versus the type, which if I remember correctly, you might need to help me with this, but like double is a type of numeric. So class is just showing you the kind of the higher level of the data type, if I remember correctly.
Yeah, double is a type of numeric.
Yeah.
I think this is actually quite a complicated question because there's some overlap, but they can also be different.
Yeah.
Yeah, I think type of is a bit more specific. So
So it's
with
like,
numeric data, there are different types of numeric data, like doubles, integers, floats. I guess floats are doubles. Um,
yeah. So there's like kind of sub uh subtypes of like a certain class. So if you kind of think of it as kind of like a like a tree that like there's that there are classes and then there's like types within classes. But right now, you really as a start just need to know about like kind of the difference between like numeric, character, data frames, and kind of the differences in between. There is kind of nuances of like kind of how floats and doubles and all that works, but for simplicity's sake for this lesson, we'll just kind of merge all those like number like things as kind of like numeric, and then anything that's like kind of a word or anything would be a character. um yeah, but you can use type of and or class like interchangeably as long as you know the kind of nuances in kind of what they're returning back to you. That class is giving you the overall class of that object and not giving you maybe particularly that particular type of of that that object that you're asking for.
I also feel like, and I could be wrong, I feel like type of is related to the data structure, whereas the class is more like the what's in the structure. Like that's not quite what it is, but sort of. And like this is a bit beyond beginner, but like you can create your own class of objects. Like you could create an object called dog, and it could have attributes like name and breed and sound it makes. And then so the class of that object would be dog, but maybe it's the type is like a data frame. I could be wrong. That's kind of how I understand it. But I feel like that's, yeah, a bit beyond the scope of this workshop anyway.
Yeah, but if people have any questions or kind of want to follow up on that, happy to chat further kind of maybe at the end of the workshop on the nuances of that. But to prevent us from getting too much more like derailed, I'll get back to the simple cats data frame that we have right now and throw in new R chunk. I realized in the original lesson here that we're trying to get us to read the CSV, and when we run the CSV and get the type of, we in the older versions of R, if we check the type of cat's weight again, we would get something different than what we had before. So it would say character instead of double, but that is thankfully something that we don't have to worry about now with our versions 4.0 and after. So thankfully, as what we have now, when you write the CSV and you read back the CSV, you will get the same types for that columns that you have in your data frame as you intended it to be. But in previous versions, you would be greeted with something something different, and you'd have to make sure that you either change the type afterwards, or make sure that you set up the right CSV or the read CSV to not do that. But since it's all good and the correct type, then we can move on and look into the CATS data frame a bit more. So sometimes we want to know all the types of the data frame just to make sure that what read CSV did was correct and interpreted all the columns as we expected. But if you had to do type of on every single column of the CATS data frame, then that could be quite cumbersome. So instead of that, we can use structure, str, and then CATS. We've done that, then you should get this nice summary here that we have a data frame of 3 observations and 3 variables, and we have these 3 columns here, and then in this second column here we have CHR, which is character, num, which is numeric, and then integer. So yeah, overall, just looking at this, looks like read.csv has interpreted the columns correctly as coat as character, and then weight as like numbers, and also like string as integer, which is like a type of numeric as well. So now that we have that, we can also look into a bit of get to the first challenge. I'm just gonna go back now that we have the data frame.
So Jasmine, we're nearing the 7 p.m. hour mark. So do you want to take a break after this challenge?
Yeah, that sounds good. Thanks for the reminder. So yeah, we have this first challenge here on the CAT data set that we have, and we have a little code template here with a couple of items that you can go through and try out. So I'll add some bullet points here so you can fill out your answers as you go. Oh no, why is it not going? We'll leave that up here for people to do, and I'll give everybody a couple minutes to go through the challenge 1, to fill out these couple of items. They should be all items that we've just went through. This is a recap of what we did. So once you're done, put in a green check mark, so I know where people are at. Yeah, maybe what would make more sense is we'll give a 5-minute break, maybe at 7, and then come back to just go over the answers and then restart from there. So feel free to get up and stretch if you need a little bit of a break from the computer first before attempting the challenge. Feel free to do that, but I'll give kind of until 7:05 and we'll reconvene.
We're gonna be here during, well, I'll be here during the break. So if you have any questions about code from the first hour, feel free to ask us during the break.
Yuko, was there any questions in the chat that we should also go over during the break? Or like after we come back from the break, I should say.
There's one question now that I actually don't know the answer to. So for this challenge, where are we getting the feline data version 2.csv from?
The version 2, I thought. Let me just double check. Thanks for checking. Because I did skip a bunch over here. Oh, I guess didn't realize that this this lesson probably assumes that there's like some data that is already preloaded, so it looks like we don't actually have it. So sorry about that. Feel free to ignore the challenge then, and then we'll come back and maybe do different challenge later. For some reason I thought that I included it. Alright, because it did I change up the lesson too much? Oh, because I didn't save it exactly the same way as
Oh, so it is the same CSV file, but they just named it differently.
Yeah, they just named it feline data _2. So you should just be able to use the cats data frame to complete the challenge. It's the exact same data frame. Thanks for clarifying that. I didn't realize that it said that. So I'm going to remove that so it's clear. So you'll just be using that cats data frame. I'll add the ... slash because in the original lesson they were reading. They probably weren't using our markdown files, so they didn't have the same issue with us.
Well, our markdowns are spin on it on the lesson, I guess.
Keeping us on our toes. And yes, for Julia. Yes, we should be using the feline data that we created. I think Catherine pointed out earlier that because we saved the file name slightly differently than the lesson, when I copy and pasted the challenge information, it kept their file name and not with our file name. So sorry for the confusion there. It's just the file that we saved. So what you see here in read data is the correct one now. It's 7:05 right now. How's everybody doing? Have people at least done the first 3 items on the challenge? You get a show of green check marks if you've at least done from 1 to 3, if not more. When we first created the table, there was a row. There was a row called like string. What was the function of this row? Oh, so like, so far were you referring to the like string column? Like string column, that what that column is used for. We haven't used that quite yet. So I think if we get to yes.
Yes. What how is it used? Why are we using this?
Oh, why are we using that column? So that I don't know if we'll get to it later in using it, because I might need to cut off some items, but the 1 and 0 is just to denote if that particular cat like string or not. So I can't remember which one they denoted, like 1 being like yes and 0 being like no. But I don't think we'll be able to get to that. But right now you can just treat it as just another column in this data frame. If the creator of the data frame was a little bit better with their kind of documentation and everything, they should also provide some information, kind of maybe usually in a separate file, on kind of the definitions for this CSV file, and give you some information about what does coat mean, what does weight mean, and what does like string mean, and help you be able to decode what is actually in the data. And that's actually kind of like a frustration with a lot of people working with other people's data, because you can give these like cryptic column names and not really know what they're referring to. So you really need kind of the additional metadata, data about the data on these CSV files for really other people to use it. So this is actually a really relevant and good point when we kind of create these columns. You can really put anything in them, but you really need to document your data to make sure other people can also use them.
So I think a lot of people are noticing that the cat's data frame that you guys have only has 3 columns, but the challenge refers to a 4th column. And it's because it is a different data frame. So there is a 4th column, I guess. Is that what people are
They were
noticing?
they're referring to number 4, where it's like the 4th weight data point.
Oh, I see. Sorry,
We
I
haven't
misunderstood.
gone through yet. I should have crossed out this item, but to clarify here, it's getting the 4th item from the cat's weight column, and here it's assigning that item in the 4th spot to 2.35, which is changing that value there. So I can go into Posit Cloud, and then it'll show you what that looks like. So if I pasted that in here, and before I run that, I would look at cat's weight for bracket. So I wrote that that's NA right now. So oh, because this one doesn't have the 4th row, so it can't do that because our data frame only has 3 rows right now. So that's why it's giving me this error. That replacement has 4 rows and data has 3. So if I'm going to replace the 3rd instead, that one was slightly different. Be able to run that, and that should be successful. So if you look back at cat's weight 3 again, and look at that, that value is 2.35 rather than what we had before in the data frame, which was 3.2. Yeah, sorry for all the confusion with the data frames, but hope everybody was able to at least get the first couple of items figured out, like printing the data. So be able to print cats and get the data frame to show up. And then for the second item, we'll pull up the challenge again. Print the data and then show overview data of all types. So these cats to get that again showing, and then oh, because we don't have the incorrect data type, but if you still go type O cats dollar weight, then you should get that data type, but because there's no incorrect data type, then we can ignore that. We went through number 4, which was replacing that value, and then number 5 was correcting the data type, which we didn't need to because it was already corrected. But if we wanted to change the data type, we could use the as.dot functions to force it to either like a character, or in this case we would want numeric value and force the cat's weight to the correct type that we wanted, and then assign it back to cat's $ weight here. And then that, and then when you check the type of, again, if it was incorrect, it should be corrected to the numeric. So yes, so this was the challenge 1. Sorry for the confusion there. I didn't realize that what we had was slightly different from the lesson's original intention, but if you have any questions about that, feel free to ask them in the chat, or come talk to us after the lesson to clarify anything. But I will move on now to the section on exploring data frames. I'm just going to create a new header here to denote that. Create a new code chunk here. And then in this code chunk, I'm going to create this new vector called age. And this is some new information that I want to add to the cats data frame that I was creating earlier. So the age, I'm just going to put a bunch of numbers, which are different ages. I'm just going to put 2, 3, 5 as ages. So now I have this age vector, 2, 3, 5, and you can see it show up in your environment here, showing the age and values that we gave it. So this is the numeric vector. So how do we go about attaching this to what we already had, which was cats, which we only have 3 columns for? So to do that, to combine both age and cats, we can use this new function. I'm just going to create a new chunk here called cbind. And what cbind does will combine the column, a new column to kind of a data frame or another vector. So in this case, I want to combine cats and add age as a column to it. So if I just run that, I should see now coat, weight, like string, and also age that's attached to it. So perfect. That was what I wanted. But what happens if I go back up here to age and add an additional age here, like 6. I run that now. My age, I've included this additional age of 6, and if I try to come back here, sorry, to cbind and rerun this with my new age vector of 4 items here, and I run that, I get an error. So in the error, it says arguments imply differing number of rows, 3 and 4. So what's going on here? So we're trying to combine age into cats, which only has, as we can see in the environment here, 3 observations and 3 variables. So we're trying to combine something with 4 rows here into something that has 3, and R doesn't know how to deal with that. And an easy way to check how many rows are in your cats data frame is just create a new chunk and do nrow cats. I run that, that's 3, and 3 is the rows for cats. And then if I check the length of the age vector that we created earlier, length age, that was 4. So knowing this for cats being 3 and the length of age being 4, that is incompatible. So we won't be able to combine these together easily. So we'll have to go back to what we had before of just 3 ages. And doing that, we will be able to combine those 2 together successfully and add that age column. So the takeaway here is to make sure the number of rows for your data frame is the same as the length of what you're trying to add to it is the same, so that they're compatible and you can combine them. And to check for number of rows in a data frame, you can use n rows. And for vectors, that's slightly different because you're working with vectors. You have to use the function of length. So you really need to remember what data you're working with and to use the appropriate function to figure out either the number of rows for a data frame or the length for a vector that we have here, like age. Okay, so now that we've added columns, I'm gonna skip adding rows for now and then jump quickly to our more realistic example using the Gapminder data set. So we don't have this Gapminder data right now, but we can get the Gapminder using file using a URL. I'll paste it in the chat here. So everybody
do you see the question too, Jasmine?
When you use cbind, does this update the .csv file that we created with cat? So Catherine, are you referring to this file that we created back here? Let me just navigate back to data. So this feline data.csv file that we earlier. Yes. So if we open up that file and look into it, we see that nothing has changed here. It's still the same as what we have initially written to it way back when in many lines earlier when we wrote that CSV file. So R only does what you tell it to do, and we've only told it to write that CSV at this one point in time. So it won't automatically go and update that feline-data.csv file here. So it'll remain the same until you tell it to rewrite again. And I think if I move over this quickly, you can see in the modified that it hasn't been modified since 623 way back when. So that's also a good indicator to see when your file has last been modified. So not until, I'm gonna just scroll down here and create a new code chunk and put in the write.csv again. So not until you tell R to execute the write.csv again, nothing will happen to that CSV file. But since just right now, I told it to write.csv again, so you should see in the modified that 7:23 p.m. has updated. So I can go and look at that CSV file. Oh, right, I didn't. If I wanted the changes from the cats file, then I will have to save this again to cats. I'm overwriting the cats data frame again for simplicity, but sometimes you might want to name it something else so you're not overwriting it. But that allows me to continue using the cats variable in the write.csv. So if I run that again and then look at the feline data, then now it has the age as well in here. So yeah.
Thanks.
No problem.
Hey, Jasmine, instead of trying to save the data externally, why don't we just install the Gapminder library, then it'll auto import. I think there's always lots of issues with the Gapminder data set.
To import it with right. Oh, so you're just
So
saying
do install.packages Gapminder, and then you can kind of download the data that way.
yeah, that's also one way as well. So the Gapminder data set, as you just mentioned, if we hit install.packages Gapminder, I'll also paste it on the chat. Oops, I don't see that. The Gapminder data set here. The data is available in a package. So instead of functions in this package, there's like a data frame in here that we can use that's called Gapminder. So if we go after you've successfully installed it using install.packages down here, then in your R Markdown, you can go library Gapminder, and RStudio should already help you auto complete that. And that will load in the Gapminder data set, and then you should be able to do Gapminder. Enter that and see the Gapminder data frame. Yeah, can I get a green check from everybody if they got to this step? While everybody does that, I will just show you something neat about R that I was trying to allude to earlier. That's the kind of longer way around this if you're working with data that doesn't come in a convenient package like Gapminder. Gapminder is used a lot for teaching, so that's why it's available in a package, but a lot of times your data might not be in a package. So a lot of our functions will take URLs. So what I was providing before was just a URL to the Gapminder CSV file available somewhere, and this will allow us to download the file. Oh, I forgot the argument to where I want to save it, so I'm just going to save it in the data folder just to show. Oh, I need you to give it a name. Downloaded. So there's also additional functions here in R that allows you to download the file by writing this line of code. So you don't even have to go to this particular URL, save it, come back to R here, and then upload the file. You can do that all with this one line using this download.file function. So that's just another option to get your data in here. But for today, we will just get the Gapminder data set using the Gapminder package. So it looks like people have gotten the Gapminder library installed and is able to see the Gapminder data frame here. So if you've installed it properly, you should be able to do library Gapminder and then Gapminder here to see a preview of the data frame here. If you have any questions, feel free to put it in the chat. I'm gonna make the console a bit smaller right now. So yeah, we see a preview of the data frame. There's quite a few columns. So what I'm going to do is create a new code chunk. And then for Gapminder here, I'm going to put it in struct str to just get an idea of what data we have. So we see that this is a tibble, which is a type of data frame. That's kind of another different data type here, but for simplicity's sake, today just treat tibble as a data frame, just a type of data with columns and rows. And then here you can see that we have country, continent, this new thing called factors. I don't know if we'll be able to go into that in detail today, but just know that this is a different data type for now. And then we have year, life expectancy, population, GDP per cap. Yeah, so good to know when you're looking at a new data frame, kind of what you're working with, so you can have an idea of kind of what you've just read in. And then it's also helpful to kind of use a function, like summary on Gapminder. So instead of just kind of getting all the info here, just to get some summary stats of the data, so you know what you're working with, you can use the function summary on Gapminder, and that'll give you some of this info. And of course, as what we did before with the CATS data, you can use typo to kind of look at a particular column in Gapminder. Correctly, country, get the type of country. Perfect. So yeah, we've taken a look at Gapminder, and then let's see, is there any appropriate challenges? Start with something. Maybe we won't go into those challenges in particular, but just showing that you can do the same thing with the Gapminder data frame as what we did with the simpler data frame CATS. We do a row on it. Check that out. This has 1,704 rows. No way I'm gonna type that out myself in R, so I'm definitely gonna get this data from somewhere else where somebody else has already entered the data or extracted it elsewhere. You can also, as a complement to nrow, does nqual. So number of columns of Gapminder, 6. So yeah, sometimes this information is good to know, and you can also get this information both at once using the dim function on Gapminder. Get the number of rows as well as the columns. And then one pretty helpful one, sometimes you don't want to just look at the columns kind of as you tab through them, but you just want to see all the column names of Gapminder. You can use all names. Yeah. You get all the column names there. So this doesn't look that useful right now, because right now you can easily look at the data frame in this convenient preview here in R Markdown and see most of the columns here without much issue, but you might be working with larger data frames where maybe you can't even load this preview without it taking it a very long time. So you might want to use functions like structure, str, type of, nrow, and call, dim, call names to help you kind of inspect this new data frame that you've received and take a look at what is available and what you're working with before you dive into plotting and visualizing the data and kind of trying to get to know it that way. I'm just going to pause for a second if there's any questions. Otherwise, I'll maybe look to use the last 20 or so minutes to jump into a little bit. Maybe I'll skip the subsetting for now and then go into a little bit of plotting that's a bit more exciting, and plot the Gapminder data set that we have right now. Like questions at the moment, so we'll create a new section down here in my R Markdown on creating fonts with I'm going to create a new code chunk here. Scroll down, create a new code chunk. So here, I will need to, in order to start plotting with R, there is a base R package, but the functionality of that is sometimes limited. So instead we're going to use is the ggplot2 package, and that's part of the tidyverse. So I believe everybody has the tidyverse already, but if you don't already do, you can go into your console and instead of installing the entire ggplot library, the tidyverse library at one go, to make your installation a little bit shorter, just to install the so you're installing this particular package. But if you already have it already, you won't need to do that. You can just go library, and then two, just tap completed that. Yes, if you have the library ggplot2, this should run without any issue. If you're having an error pop up, that means that you probably either misspelled ggplot2 or you will need to install the package. So you'll just need to run that install packages command for this ggplot2 package, and you should be good to go. So ggplot2 is the grammar of graphics. It's a pretty powerful package that allows you to create a lot of different types of plots, from simple scatter plots to kind of even maps and animated plots if you kind of use additional packages that extend ggplot2. So a lot of people in the R community have graciously put their time into making this plotting library even greater and have additional functionality. So oftentimes if you can't find something that works for you in just the base ggplot2 package, there might be an additional package out there in the world that will help you. So sometimes a quick Google search will yield a lot of cool results. So I encourage you to go out there and look for all the different cool things that you can create with ggplot2. Yeah, today we will start with basic plots in ggplot using the Gapminder data set that we were looking at before. So all ggplot plots start with no surprise ggplot, and then ggplot here. There's an argument data, and then within data we want to pass it Gapminder, which is the data we want to plot. So if we just run this right away, we get an empty canvas here with just the gray blocks. So right now we haven't really told ggplot kind of what we want to plot yet. So right now at the very base of this, ggplot only puts up kind of the basic empty canvas. So we need to tell ggplot what to kind of paint on this canvas. So I'm going to add an AS variable, which is aesthetics. These are the mapping aesthetics where we'll put in what we want on the X and Y axis. In this case, maybe I'm curious about mapping on the X, the GDP per cap column, and then I'm also interested in maybe the on the y-axis to show the life expectancy. So yeah, adding these two things, I'm gonna rerun this again. So a little bit more rich now. I've added in on top of the blank canvas the life expectancy on the y-axis and the GDP per cap on the x-axis. So yeah, a little bit more information, but still we don't have any points on here. So how do we add that on here? So ggplot kind of works in kind of a layering system. They have different kind of ways you can add different plot types by using these functions called that start with geom. So to add that to our ggplot function, we need to use the plus symbol. So this plus symbol will just help us chain together multiple functions into one ggplot. So make sure that you have this plus after ggplot. Then after the plus, we're going to add a geom, a geom underscore, and you can already see once I started writing geom underscore, we get all these options from ggplot2. It's also helpful to see kind of in this drop down here that beside each of the function names, there's the package it's from. So that's easy. That helps you identify which package is from. In this case, all of them are from ggplot2. But if maybe you install other packages, you might see other packages show up here. So yeah, so I've just started with geom, and you can already see a bunch of geoms showed up. There's a whole bunch of options, bar, area, box plot, and whatnot. Some of these might be familiar to you. Some of these might be a little bit foreign, but you can look into the additional help documentation or find other tutorials online to create plots of your interests that you want to create. But for this lesson here, we're going to start with a simple scatter plot. So I'm going to go G on point. And then that's all I have to do. And if I run that, I should get a plot with life expectancy and GDP per cap with these points in the spread. Yeah, everybody should be able to get this plot so far. I show get a show of green check marks if everybody has a nice working GG plot available to them right now and they've been able to get to this point. Cool. Looks like everybody's able to create a plot. So awesome. And then now I think we should be able to go back to one of the challenges. I think we have to go quite far down to go down to this section here, creating publication quality graphics. So I just opened up the document outline in the Google Doc here to quickly jump over to this section. And then you can modify the challenge here to show in the figure the life expectancy over time. And I'll create some space here if you want to put in there. We'll give people 2 minutes to try that out. A hint might be helpful to know that there is a column called year in the Gapminder data set. And what we want to do is show that on the x-axis. So how do we modify this ggplot call to do that? I'll give people another minute before going over there. If you're stuck or anything, feel free to unmute or chat in the chat and I will help you debug. people have put their names on the document, or people having issues with showing the life expectancy changing over time. You can copy the code that you maybe had running in your R Markdown over to the collaborative notebook if you want, or if you want to share your answer by unmuting, that is totally cool too and welcome. But I'll switch back over to the Posit Cloud over here and go to my ggplot. So can somebody suggest what I should be changing in order to show the change of life expectancy over time? Maybe everybody's a bit shy today, but I can go change the aesthetic variable here from GDP per cap to year. I'll run that, and you should get a plot similar to this, where we have year on the x-axis and life expectancy on the y-axis. So yeah, you can change the AES here for the x and y variables to any of the columns that you can find in Gapminder and plot anything that your heart desires there as using the geom point. I'll also do should have enough time to go over the line example. So I'm just going to create a chunk here and go over that before the end of day today. So I'm going to take the same ggplot code that we had earlier. So Gapminder. And then I'll do AES. Put in x equals year. Y is equal to life expectancy, and then on top of that you can add in the aesthetic function here within the brackets, you can also add color. And color, you can put a specific color or a variable you want to color by. So for the color, you can pick something like this time, instead of a geom point, we will do a geom line instead. I'll make a line. Yeah, that creates this plot here, but it's kind of slightly different than what we expected. The lines don't seem to connect properly. So what's happening here? So we're trying to color by line, but it's not showing it per country. So how do we fix that? By adding inside the AES here, by adding an additional variable called group, and that allows us to group the color, the values by a specific variable in Gapminder. So in Gapminder, there is a column for country. So we're going to add that to it. When we run that, this looks kind of more what we expect, that each line represents a country, part of the continent. So that makes a little bit more sense compared to what we had before, where the lines were disjointed because it was just trying to combine, connect everything for that one continent together. So by using grouping, that allows us to group the data by country so that when we go to color it and show the lines are connecting by each country inside that one continent. So yeah, I think that's all we can reasonably cover for ggplot2 for this lesson, but hopefully that gave you a little bit of a taste on kind of what you can do with R plotting wise. And we will definitely revisit this again in a subsequent part. And we'll go into more depth on like kind of what you can plot with the ggplot. But yeah, this is the basics of plotting. Hope to see everybody in the next part next week, same time on Wednesday. If you have any questions, all of us organizers will stick around for any of that. If you want clarification or have a question of your own in your own work, feel free to ask us that. But yeah, thank you everybody for sticking around and learning about a little bit about data structures in R and how to read a data frame, write a data frame, and then plot a little bit more complicated data in R. Yeah, and feel free to maybe try that out in the week in between now and the next week.
Yeah, and before everyone leaves today, please fill out our sticky note feedback form. I posted a link in the chat. This will really help us improve let us know what went well today and how we can improve for part 3. Thanks,
Yeah.
guys.
Can also be accessed from the collaborative doc here. Look into that and fill out your tab. Yeah, fill it out. One negative and one positive comment on what kind of went well during this session and what could have went better. So yeah, anything you can provide would be helpful.
Yeah, sorry, I just made it so that anyone can access. I just noticed that. Thanks. You should, if you refresh the page, it should work now.
Feel free to unmute if you have any questions. Oh, can you stop the recording?
Oh, yeah.